Hello and welcome back. Today we're back on the Quadratrac transfer case. In the last video we tore apart the low range unit, and at the beginning of this video I'd like to show a little bit the internal operation of the low range. So this is these are the planetary gears and carrier of the planetary gear set, and this is what actually drives the transfer case. It connects here to this shaft and drives the internals of the case. It's held on by a snap ring, but we won't do that right now. Of course, this is the sun gear and then main shaft. The sun gear goes like this. This is the planetary locking plate, essentially. It meshes into the planetary cage. And then, of course, the ring gear. And after that we have the reduction collar plate hub, which locks into the plate that drives the ring gear. That. Then we have the reduction collar hub. You can see that it is not driven by the shaft. Neither is this hub. Actually, it goes on the outside of the shift collar hub. And again, the shift collar hub is not driven by the main shaft. It's smooth, but these splines reach through and grab the locking plate on the inside, like that. Then we have the direct drive collar here, and then of course we had in the back of the case we took out the shift collar, and this is really what does the changing from high range to low range. You can see it is splined internally, and the important part is when you're in high range, the shift collar is in this position, back position, and then of course there was a holding plate that's fixed to the case. In this configuration, in high range, the holding plate rides here and is not engaged to anything, so it doesn't do anything in the high range case. The important part here is the internal splines of the shift collar grab the direct drive sleeve. So then, in the high range position, a little tricky to hold together without it being in the case. Okay. In the high range position, what that does, the torque is transmitted all the way through this shaft. It doesn't drive any of these except for the sun gear, and then it drives the direct drive sleeve, which is connected to the shift collar, which then transmits the torque back down through the gear train, and essentially locks all of this together, and it just turns as one big unit. There's no gear reduction. It's really no different than the unit without the reduction, where there's just a drive hub here. All of this accomplishes the same thing, a 1-to-1 ratio. So when you shift the lever forward into low range, the outer teeth on the shift collar grab the inner teeth on this holding plate and makes the collar stationary. I can't hold that all at once, but also as the collar comes forward and engages the plate, it grabs this reduction hub on the ring gear and releases the direct drive hub, and the shift collar hub. So now, remember, this is held by the ring, so it can't turn. So what the effect of that is then is the ring gear is not allowed to turn, and that makes the sun gear spin the planets inside the ring gear. And you can actually see here the direct drive hub, of course, is still spinning at the same speed, but everything else is spinning, well, a bit slower, right? So that's the gear reduction. So that's how the low range works. You can also see that there's no synchronizers to make all this happen. So if you've ever driven one of these, you know it's easy to grind the gears trying to go from high range to low range, and what that is these gears trying to mesh to the holding plate. And in my experience, you basically need to almost stop the vehicle. You can shift it smoothly, going about 1 mile per hour. So what you do is shift the transmission to neutral. If you're going downhill, you can control your speed with your brakes, get down to 1-2 miles an hour, and then you can mesh these gears together without grinding. Much harder to do going uphill. What I find, it's easier just to sometimes stop, shut off the vehicle, put it in low range, and then fire it back up and go. So that's sort of the grinding problem with shifting these unsynchronized gears. So anyway, that's how it achieves the low range gear reduction. And then just one more thing I'll point out. Of course, these planetary gear sets have different formulas for calculating the gear ratio depending on which part is being driven or held stationary, or which one is the output shaft. So in this case, of course, the sun gear is being driven by the transmission, and for the low range, the ring gear is held fixed. And so the formula for that is to add up the number of teeth in the ring gear, which I count to be 66, and then add up the number of teeth on the sun gear, which I calculate to be 42. Add those together, you get 108. And then the formula is to divide that 108 by the number of teeth on the sun gear, which is 42. So 108 divided by 42 equals 2.57, which is the gear reduction ratio of this case. Right, so in the previous video, I mentioned that these 10 spline shafts can cause a bit of a problem by wearing quickly over time versus like a finer spline, 20 or 30 spline shaft. So see here we have 10 splines where the output shaft of the transmission connects, and then the main shaft of the low range unit is basically the same spline. And what that does is when you, well, first of all, this transfer case was only ever mated to one transmission. It's the Jeep version of the General Motors Turbo Hydromatic 400 or Turbo 400. And so what happens when these splines wear is you shift into drive or reverse, and you can get a pretty loud bang, which I'll try to demonstrate now. Initially, that loud bang is just more annoyance, but eventually it gets worse and worse, and at some point you need to address it and find a donor case with a better shaft is about the only option to address that problem. So before I take the case apart, I'll point out a few things about it. One, it is a full-time four-wheel drive transfer case, which is unusual. So it's a chain drive. There's a drive gear here and actually a differential here. It's driven by a wide chain, and that way the front and the rear drive shafts are always engaged. And of course, since they are always engaged on pavement with high traction, you need some way for them to spin at different angles when you go around the turn. So that's why there's essentially a differential, just like in your axles on this side. And we'll get into the differential once we have the case open. But one of the potential problems with this case is the chain stretches over time, and it can eventually start jumping the gears. And so Borg Warner made a provision to check the tension of the chain to see if it needs to be replaced. And for that, then the vehicle will be down toward the bench here, but I need to flip it over so you guys can see. There's a little pipe plug access port, just a hole in the bottom of the case. And of course, after draining fluid, which since we're here, this is the plug for draining the fluid. So that's literally the first step. So pull that, all your fluid will drain out. Alright, so that's just a 1/4 inch pipe plug there. The other one is 1/2 inch NPT, and one's 1/4 NPT. And Jeep provided a special tool to measure the chain tension, but of course no one has that tool anymore. And so the thinking over the years seems to have become, you stick a screwdriver in the hole and touch the chain, and then you don't want to feel more than about a 1/2 inch deflection. That's been sort of the way people have been doing it. So regardless how you measure it, you want to make sure there's no tension on the chain. So that might mean putting a neutral, disconnecting your drive shafts, depending on which version of the case you have. So I will turn it in the direction to make sure all the slack is here, since it's going to be hard to demonstrate the way it is in the vehicle. So you guys might not be able to see this very well, but that's okay. So if I now the slack should be on this side. If I touch this chain and then press in, it goes in at least 1 inch or 1.25 inches. So by the 1/2 inch rule, of course, that would be completely worn out chain. As it turns out, I happened to find one of those chain tension inspection tools recently. It's the first time I'd ever actually seen one in person. It's a J25162. Right, and basically it screws into the case bore until it's flush with the case on this shoulder. And there's a little plunger inside and a spring. So it's a compression spring, and then just a simple rod with a C-clip on it to catch against the, not let it fall out of the bottom of the tube here, and push against the spring. So very simple. And then this has a machine shoulder and stops, so it's very fixed distance. So anyway, you screw this in. It puts quite a bit of tension on the chain, and it should give you an accurate measurement of whether you need to replace the chain or not. And so the rule essentially is, make sure I don't have any tension on the chain here, is this plunger should actually protrude past the end of this cap, and you can see there's no plunger protruding there. Let's see if we can see the plunger. I can see it, but I don't know if you guys can. So it is at most 1/8 inch, probably less, down into the bore. So that would mean this chain is just slightly past good, right? So with my screwdriver, I measure 1.25 inches of slack. So something doesn't add up. It would seem that a 1/2 inch rule of thumb that we've used over the years is maybe a little conservative. So you'd be changing your chain sooner than you need to. Of course, that's, for peace of mind, that's fine. But then again, maybe you're spending money you don't need to spend to buy a new chain. So anyway, with this tool, then I think we can come up with a better way, a more exact way to measure the slack in the chain, whether we need to replace it or not. And so we'll get to that later. I'll also show you this when I have the case apart. But that's that for now. We'll come back to it. And then you can go ahead and split the case open now. But one thing I like to do is to go ahead and break the yokes nuts free. You don't necessarily need to remove the yokes, and you don't need to remove the yokes to split the case, but these get rusted on here. They're only tightened to something like 110, 120 foot-pound, but then they rust, and so it takes a lot more than that to take them off. So we'll attempt to do that. I've already loosened the rear output shaft, and we'll try to loosen the front output shaft. I did spray some PV blaster on it a long time ago, so I don't know if that actually helps or not. But and then, probably like a lot of you have done, try to grab this with like a pipe wrench or something to hold it while you loosen this nut, and it's always cumbersome and difficult. So since I decided I was going to do a few yokes now and then, and this will do pinions as well, but one of these yoke holding tools. Several people sell these. I think I bought this one from the Bleepin' Jeep YouTube channel just to support those guys over there. But basically it has a few different bolt patterns to match up to different yokes. There's a big hole in the center for your socket to go through. This is the 1/2-inch drive, so you can put a breaker bar to hold it, or if you prefer, you can, I believe it's 3/4 inch iron pipe. You can slide over this tab and get some more leverage on it. So let's match up two of the bolts here. Let me turn this a little bit. That should work. So let's use a couple of the bolts that are already on the yoke. Like that's good enough. And then what that allows you to do, of course, is there socket can go in to grab the lock nut, and then your 1/2-inch extension can go, well, not across the hole, right? So like that. So I'm going to get this in a position where I can put some force onto it, hopefully. I'm not sure if I can really do this on camera. I might need to bring it to the ground, but the reason I recommend breaking these nuts loose is with all the case together, there's plenty of weight. If you wait till the end and you just have this lightweight case and one shaft and yoke, and you put a huge amount of force to break this free, it wants to jump around on you. So it's a little easier if you, do it while the case is still together. Inch and 1/8 socket. I happen to have a 3/4 inch drive ratchet that I never really get to use for anything, except for things like this. Then we can snap in our breaker bar to the yoke tool. Like that. If all goes well, break this free. Even that's not going to work. Alright. I'm going to have to get this off the bench where I can get some more leverage on it. I'll be right back, but I think you guys get the idea. Okay, that took quite a lot of force. The nut was really rusted on there. I ended up standing on the breaker bar with both feet and then getting both hands on the pipe on the end of this large ratchet. And I don't know, it probably took 300 foot-pounds or more, 400 pounds. Anyway, it's loose now. And the yoke tool did its job, made that much easier than it would have been otherwise. Like I said, you can take the yoke off now or not, it doesn't matter. Just want to get the bolt loose. I think I'll just leave it on for the moment. Get our yoke tool out of the way. The case is held together by several 3/8 inch bolts, but there's a couple of things I like to go ahead and take off before the case is apart. So this is the plug where you fill the case with fluid. It's 3/4 inch NPT. And then this, there is a switch that indicates when the case is in what's called emergency drive or not, which we haven't covered yet, but we'll get to that. And it blocks one of the bolts from coming out. So pull this switch out. Alright, and then if you just need to replace the chain or do any number of maintenance items, you can actually do it in the vehicle. So this is the front half of the case toward the front drive shaft. So you can actually leave this bolted to the transmission tail shaft adapter, pull off the back of the case and do quite a bit of maintenance from there. Obviously we're out of the vehicle here, so I need to get a couple blocks of wood and make it just a little more level so you guys can see what I'm doing, I think. So it's a couple of 2x4s stacked up there. Except stable enough, I guess. So some of the bolts that hold the case together, well, I took out in the last video. These 3 bolts held on to the low range unit or the cover, and those are two long 3/8 bolts and one short one, and then the rest are still in. So pull those out now. Alright, so in principle then the case just splits in half. Of course, sometimes when people rebuild these, they put them together, they use RTV or any number of things in here, so it can be a little tricky to get these started to open. So what I do, if it's really stuck, is I take a razor blade and a small hammer, and tap it all the way around the edge and start to get a small gap so you can get a bigger, like a pry bar or screwdriver into. But if you do that, wear safety glasses, because you're not supposed to hammer on razor blades. They are brittle and they will possibly break off and get into your eye. So, fair warning. Let's see what we get into here. Sometimes leaving a bolt in giving it a bit of a tap will get things started. That's close. Okay, that should pretty much do it then. There we go. Alright, so here we are, what the inside of the case looks like. So this is just a big drive gear that turns the chain, which then in turn turns this differential. And of course, while we have a good view here, let's just quickly show what the chain tensioner tool does. Alright, as simple as that. So, this chain, I can tell just by looking at it how it is in fact worn out, and sometimes if they're really worn, you'll see them a little bit of wear mark where this chain's been dragging on the case. Anyway, that's how the tool works. And then whether it's in the vehicle or on the bench, you can actually either simply lift these two out, or what I think is easier on the bench is to flip it over and pull the case off of these two, leave them behind. You'll notice, looking at a few different ones of these, there's some of the cases have an O-ring groove, some of them do not. See if I can find an example of one that has one. Alright, so this is an example of the rear part of the case, a different one. You can see, get the other one over here. Stay there. There you go. Alright, see there's a O-ring groove here. And the case we just took apart, no O-ring groove. I was not able to determine why some of them have grooves, if it's different year models or what. So if you know, drop that information down in the comments for the rest of us. So I don't think I mentioned what the problem is with the chain stretching. Eventually, if it stretches too much, it'll start jumping on the teeth on these drive gear or the differential, and that can actually then break the chain. If it breaks the chain while it's all spinning, of course this aluminum case gets very easily destroyed, and that's sort of game over for that case. So anyway, let's move the back half of the case. And this differential sticks a little higher up than this, so I'm going to leave one block of wood underneath. Try to flip this guy over. that. And then it's rather easy to separate the case from the drive gear and the differential. So we clearly need to replace the chain. I'll get into replacement parts and where to source them and that sort of thing in the rebuild video, but this is trash. I'll just point out that this is this transfer case is sort of a reputation for being a bit on the weak side because of the chain, but as you can see, this is a massive heavy chain and it's not worn, right? So the problem is the links stretch a little over time. If Borg had put a some sort of tensioning device on the chain, this chain would be perfectly fine. I would run it without any concern, but unfortunately they didn't, so we need to replace it. So that's junk. This is the main drive sprocket that gets driven by the planetary gear set of the drive hub that I showed you from the low range unit, and this is just one solid machined piece. There's a thrust washer here. That's a wear item, so that can be replaced. We'll get a new one of those and replace it, but really there's nothing to do here but throw it in the solvent washer or however you like to clean your parts and clean it up, and it should be good to go again. Okay, before I take apart this differential unit and show you how it works, I'll first explain a little bit how the overall system works. So this is the rear of the case, and because this differential can slip to allow the front drive shaft to turn at a different speed than the rear drive shaft, there's basically a clutch in here. Limited slip differential is what you end up with. But if say you're off-road and you lose traction and spin a tire, start spinning tires, you can burn up the clutch inside of here. So to prevent that, there's something called emergency drive that basically locks out the differential and just makes equal power to the front and the rear drive shaft. So I'll attempt to show you that now. There's a little cover here. So this is just the case vent for allowing for fluctuations in temperature inside the case. It doesn't pressurize. So it's just a cover plate and sealed by an O-ring here. And behind that we find a shift fork. Shift fork down in there, and then it rides on this, or it's attached to this shaft, which is attached to this vacuum actuator. It's double acting. As you can see, it has two ports, and basically you apply engine vacuum to this side and it shifts the fork this way, and if you apply it to this side it shifts the fork that way. And then in turn, this might be impossible to see here, but there's a little drive collar in there. And when the drive collar is in the normal position, which is back, so engine vacuum pulling on this side of the diaphragm, then the differential is doing the work. It's allowed to slip. Once I pull that collar out, we'll see it a little better. But when you start spinning your tires, and at least in a CJ7, you open the glove box and you find this funny looking switch. And so once you lose traction, start spinning tires, you stop and turn to the emergency drive, and that's what basically locks out the differential. So it's just a regular four-wheel drive at that point. You can spin your tires as much as you want or as much as you need. So what this is just a vacuum switch. So engine vacuum comes, I think, to the center port here, and then depending on which way you rotate the switch, you send vacuum to one side of the diaphragm or the other. when you shift this forward, the whole rod moves, and you can see here. Try that again. This is where your four-wheel drive switch goes. There's a light on the speedometer cluster in CJ, and it says 4x4 on it. So when that rod comes forward, it's this little switch, and basically that circuit has 12 volts applied to the light in the dash at all times, and then once you do that, it provides a ground to that circuit, and the light turns on. That way you know you're locked into the emergency drive. So that's in normal differential mode. So you can see that come forward, and that would be grabbing onto these gears on the differential. Now it's basically locks it out, and so it's not a differential anymore. Let's see, try that one more time. Normal. And locked in emergency. Yeah. Anyway, just want to show that before we tear the differential apart. Alright, so before you disassemble the differential, you want to mark it so it goes back together the same way somehow. So you can also indicate this as the rear, but it should be pretty obvious because there's this shoulder on this side of the unit. It's not on this side. So anyway, the rear has the locking gear and the long side, and then just somehow mark how these flanges meet on the front. It should be good enough. And then there are 8 bolts per side. Knock those out now. And just be aware there are some springs behind here that I'll show you, but yeah, it'll come off. Make those bolts a little tight and hard to get out. Go a little bit slower there. So yeah, it should have said leave 2 opposing bolts in and then back them out slowly, and then that releases slowly. The spring pressure would have been the smarter way to do that. So inside, I find a few things. These are just some side gears. All right, allow everything to turn independently. So that's the differential part, right? It looks very much like sort of what you have in your axle. And when you take these apart, you want to keep all the pieces in the same order they came out, if possible. So pay attention to that. So here's the limited slip part. This cone shape is tapered. There's a taper in the differential housing that matches the taper here. And basically those 2 conical surfaces are forced together by a series of springs. So this is just a spacer, and then there's 3 which are called Belleville springs. It looks like a washer, but they're cup shaped. And these are, definitely want to keep these in the same order they came out if you can reuse them. And those stack in there. Another spacer to get the preload on the cones, right? And then of course when you bolt it down, it compresses all those springs. And what effect that has, it creates a certain amount of friction on these two conical surfaces that do not allow the differential to turn until a certain amount of torque difference between the front and rear drive shaft has been reached, and then it will force the cones to slip. The torque difference between the front and rear drive shafts is something like 70 to 150 foot-pounds, and then these clutches will start to slip. And if you're driving these, you sort of feel it in the seat of your pants. It's a sort of a grumbling vibration that this makes when it slips. And some of those have been sitting for a while. They can pop free suddenly and make quite a loud bang, and you may, to the point you think maybe you damaged something, but it just quiets down again and it's happy. So anyway, that's the way that works. And of course, this friction, the amount of friction here is very important, and so this transfer case requires a special fluid. So basically it's a 30-weight oil that has some friction modifiers in it, like our limited slip fluid, whatever. And then that sets the right amount of friction so these can slip. So where people get into trouble, if they don't know that, they just put transmission fluid or 30-weight oil, whatever, and then it burns up these clutch faces. And you can sort of tell if that's happened because this surface will get all scored up, or if it's just run out of fluid and run dry. Let's see if we can see that a little better. Right, so these score marks here. I've seen worse, but this isn't good. I wouldn't want to run this if I didn't have to. So the problem is Jeep didn't really sell individual parts of this transmission. It was just meant to be replaced as a complete unit. Well, they of course stopped making these things a long time ago, but now recently you can actually buy new cones. So if this surface is not too bad, I'll tell you about where the cones come from in that story in the next video. But if the cones are damaged here and this surface is good, you can put in new cones. But if the unit has been taken care of with the proper fluid, changed regularly, generally these surfaces are okay. They're a little bit worn down maybe, but they're in pretty good shape. So if that happens and then they go a lot of miles, the next problem that crops up is the splines where the output shafts go into the cones. I'll show you the difference here. So this is the little side gear. It doesn't seem to wear out its teeth very much, but the cones wear out the inner splines if nothing else wears out first. And so then eventually, once they're completely gone, and you can't move the vehicle forward at all. Let's see here. Let's show this. So there's nice fully formed teeth on the side gear. And there. Now you can see those teeth are nearly worn completely away. So between the scoring and the differential cone face and these worn out gear or splines inside the cone, this is shot. So maybe with a new set of cones with that differential would work, but if I had a better option, I would go with it. If not, I guess I would run this with some new cones. Anyway, we'll get to the new cone story later. So like I said, you want to keep everything in the same order that you found it, if possible. And to do that, what I do anyway, is I keep everything stacked together until I'm ready to clean everything. And then go ahead and run a zip tie through. Just to kind of keep everything in the same order. And then when I'm cleaning stuff, I put them them all in a stack, clean them, lay them out in a row in the right order, and put them back together in the right order. If you don't do that, so I understand, your Belleville springs may wear faster if you get them out of order, or anyway, it's a good idea to keep them in order like this. So let's have a look at now the other side and see what shape the cone and the splines are in this one. Now, what I should have done last time is slowly back off of these. Until the spring pressure is released. Then we can pop the bolts all the way out. So we see the same thing on the other side. We have a spacer there. Same Belleville springs, and basically these should have a nice polished look for the most part. If they're scored up, that's also no go. Little faint marks on these, but they're in pretty good shape. I think they'll clean up just fine. Side gear teeth look quite good in this one, no problem. These really don't wear out. And the input shaft or the output shaft that rides on these must be a harder material. The splines and the shafts also don't wear out. I can show you that when we pull those out. And if we look here, it's not as bad as the front side cone as far as the splines, but there's definitely quite a bit of wear there. Would not like to run that. As far as any scoring on the cone itself, there's some maybe, but it's not too bad. And we'll run a zip tie through that side as well. And then we're left with the other side gears that run on the shaft here. And the shaft is actually held with a cross shaft that's free to move in this hole, but it's held in by the flanges when they're bolted on. But that should just slide right out like that. A steel pin, and then with that out, the shaft will come out easily if things are in pretty good shape. And you really would prefer to keep these little, I think these are just wear to prevent wear in the side of the case when these side gears spin. So probably, since these spin together, probably want to keep those matched. And until I get ready to clean, I actually won't take those out. I'll just leave them stored here on the shaft. The other thing to check while you're in here is pull these side gears and see how much side to side wobble. I'm not sure you can see that. There is a little here. If that gets too much wear, then of course you're putting too much strain on other components, and that can be a problem. That's a little more wear than I'd like, but you know, this is all about a little bit of compromise when there are no new parts available. You know, for most of this stuff, it's a game of, you know, going through junkyards and finding the good ones, right? And eventually, of course, they'll be gone. Have to do something else, or maybe someone will step up and make some parts for these. We'll see. So anyway, that's the the differential all taken apart, ready to be cleaned and reinstalled. Anyway, let's get back onto disassembling the main case. And let's go ahead and get the output yokes off. Here's the front output yoke. Of course, we already busted these nuts loose. Inch and an eighth nut. It's this type of crown lock nut. And if you're lucky, the yoke will just pull off like that. And what you find inside then is under the nut is a washer, and there should be a rubber O-ring to seal the output shaft here, but there's not. So probably explains why this case was leaking pretty badly there. I'll show you the rubber O-ring when I put everything back together. So with the yoke off, the front output shaft will come right off. And I was wrong, there's actually a O-ring here. It just went with the shaft instead of actually. Yeah, I guess it just pulled through the yoke when that dropped out. So this is not just a regular O-ring. It's has a profile to it. It's a special seal. We'll get some new ones of those. And then behind the inside of the case on the front output shaft, there's this spacer that's important. So looks like it's in fine shape. We'll reuse that. And then that's it for the front output shafts. Previously I showed you how the cone, the splines and the cones in the clutch wear. Well, they ride essentially here. You can see there's a little bit of polishing, little stripe there, but that's about all the wear the shaft gets. It doesn't wear down the splines like it does on the friction cones. Alright, let's do the same on the other side. This is the rear output shaft. And the other side, it's the same story, same nut, same spacer. On the rear output, it's a little different. This is an extra piece here. This is the speedometer gear. So let's get the speedometer gear out of there. It's 7/8. behind this speedometer cable adapter. Then there's the speedometer gear, and this adapter has a shaft seal, rubber shaft seal in it, and that sometimes leaks. Little rubber shaft seal. So we'll try to find a new one of those. Same rubber shaft seal, seal the splines. And then this is the rear output shaft. And again, you see where the friction cone splines ride, and it doesn't wear the shaft itself. And this looks a little different from the front output shaft, and has this additional gear cut into it. We'll show you what that's for when we get to it. Here we find the side cut speedometer gear that drives speedometer gear output. Then behind that, you see this is another annular deep groove ball bearing that to support the output shafts. There would normally be a seal here, shaft seal. I've already taken that one out. So actually, let me show you on the front of the case. It still has the seal in there. So this is just a typical output shaft seal, and you normally use something like this, seal puller, to yank those out. I don't particularly have good luck with these. I see other people use them, they work just fine. I think because this one's cheap. Also, some of these seals you can get to the back of them and drive them out that way. That's certainly a possibility. I like to clean up the bore a little bit before I try to pull these seals out. So like everything else with this case, since these seals have been in possibly a long time, and maybe really stuck in there. So one approach I like to do is take some heavy shears and just cut through the top level of the seal. Like that. That twice. Then you can lock onto that piece you cut out with some vice grips. Bend that up a little bit, and then just take a hammer and want to buckle the seal into the center of the bore. Once that breaks the seal or bends it enough, it comes right up. looks like someone used red RTV or maybe red Loctite to put that in, so it was definitely stuck in there. Then on the input where the transmission shaft comes into the transfer case, there's actually a double seal. One's facing out and one's facing in. What I like to do on those is simply rest it on a block of wood, something like that, a little bit softer. And then these can just be driven out with a seal driver. So find the sort of size. If you don't have drivers, you can just use any sort of aluminum disc that you may have. Could use a socket, I suppose. That fits. So then to center your driver on those seals, tap it out. Like everything else with this case, these are incredibly stuck. They normally just push right out. Let's try a bigger hammer. And those haven't moved at all. Now maybe you can see the seal starting to come out. In fact, that front one came all the way out. And the back one came out. So what we're left with is two needle bearings. These are both the same size. These seem to last a long time. They don't necessarily need to be replaced every time, but if I'm going to go to this level, I'll put in some new bearings. And then on this side we have the annular output shaft bearing. We'll do bearings later. So now in the rear half of the case, we also have some bearings. But first we need to get the emergency drive shifter mechanism disassembled. So the first thing you'll see here is a tiny little spring, and this helps secure the shaft of the vacuum diaphragm shifter into the case. It's a really small little thing. So we'll put that on a magnet so we don't lose it. Previously we took the cover for this mechanism off. There is a O-ring behind it. Replace that. So now the shifter fork is held onto the shaft by, the shaft goes through it, but it's prevented from sliding on the shaft by two E-clips. And we'll pull those out now. If I can hold it and do into the camera and do this at the same time. There's one of Here's the other one. Right after the E-clips come off, the fork is free to move on the shaft, and the shaft will pull all the way out. But you can see here on the fork, maybe there's detent ball grooves. So there's a detent ball and a spring down underneath the shaft in this hole. So that'll pop out when you pull the shaft out. So use something to catch the ball so it doesn't go flying across the room. This is a little small magnet. Hold that over the hole. Work the shaft out, and there, captured a ball, detent ball and spring. So at that point then, the shifter fork comes out, and it does have some nylon pads to aid in smooth shifting, so don't lose those. And then the vacuum diaphragm shifter mechanism is sealed to the case with an O-ring, so we'll need to pull that off and replace it. Yeah, this one's in pretty bad shape. It's pretty much shredded. Then the last piece is the locking collar that locks up the emergency drive, so that it locks out the differential and gives equal power to the front and the rear drive shaft. So if you need to spin tires, or if you're spinning tires, you lock this up and you're good to go. I'll maybe demonstrate that later. Alright, so see down in there, that's pretty much everything out. So now we're left with bearings. Similar to the low range output or main shaft bearing, these are held by two lock rings front and back. They're a certain thickness, so either keep them in order and put them back where you found them, or we'll measure them later and get them in the right spot. This is pretty deep down into the bore, so it's a little tricky to pull out, but let's give it a try. So there, I did scratch up the bore a little bit getting that out. If anybody knows the right way to get these locking rings out, put it in the comments, please. So we'll keep this one with the rear output shaft. Now, this bearing is also not a press fit, just like the low range, but it feels stuck in there. So let's see if we can push it out. always test your bearings a little bit, put a little pressure on them. This one is not in great shape. The problem is finding replacements is difficult, and I'll cover that in the next video, but it's a bit of a problem finding these bearings. So after the bearing is out, there's the one ring remaining there, and I will pry that out and push it down into the case. Once it's in the case, then you can just reach through and fish it out. And then basically it's the same story on the front half of the case with the same bearing, same snap rings. It's a little easier to get to because the bore's not as deep, but I'm actually going to leave that bearing in because I want to use that case to mock up something for a different project. But anyway, it comes out exactly the same way as this one, so just repeat on the other case. And then let me get reset up here, and we'll go after these needle bearings, which is pretty much all that's left in the case halves. Okay, next let's go after the needle bearings. There are 4 of them, 2 in each side of the case. 3 are the same size as this, and then there's one large one. To get these out, you can either tap them out with a hammer, or you can pull them, or use a puller and a slide hammer. They all work. I don't think it matters. These are straight smooth bores, but I always move them to the inside of the case. So let's first drive out the large bearing, and what we're going to do there is support it a bit. Support the case on some wood or something softer, since we're going to be hammering on it. And then use a seal and bearing driver. And let's see if we can tap that out. It can be a little tough to get started, but that one's moving now. It's almost out. And there it is, all out. This one's not in bad shape. It probably could be reused, but we'll put a new one in. Alright, there we go. Another needle bearing out, also not in bad shape, similar to the other one. And then that's it for the rear half of the case. That's fully disassembled, ready to clean up and put it back together. Now let's look at the front half of the case. similar to needle bearings. This is going to be a little bit trickier, so I think I'll leave this bearing in. Like I said, I left the annular bearing in, so it's in the way for me to drive this one out. Anyway, it drives out just the same as the other two we just showed you. I'm going to leave that one in for the time being. And then this one is the tricky one. The difficulty with this bearing is that there's no access to drive it out from the back. This bore where the shaft seals go makes a little ledge or shoulder, and this bearing doesn't actually sit on that shoulder. There's about a fingernail's width behind it. But the cheap puller set that I have, the little lips that are meant to go behind and grab the bearing and pull it are too thick to reach behind it. So the probably the correct way to do this is to have the right tool, of course, as usual. There is a collet that has a high-strength steel, much thinner lip that is probably really meant for pulling this. It costs about $250 just for the collet, $250, and maybe another $150 for the puller. And I don't mind buying specialty tools, but I didn't want to pay that just to pull one bearing now and then. So I decided to try to make the cheap set work. So I took one of the collets and I tapered down the edge to a sharper point, and that almost works, but it not quite. So let me go ahead and demonstrate. First, we need to expand the collet so that we'll try to reach into that little gap that's behind the bearing. Okay, that's too big. I have in the past cut these bearings out with a bearing cutter, but it's easy to scratch up the case but doing it that way. Okay, that sits down there by the shoulder in the case. Then you want to tighten this up quite a bit. Hopefully get those sharper edges back behind the bearing. About as far as that will go. Now, my experience when I try to pull this as is, it will probably still be too flimsy and just pop out, but let's give it a try. So I can tell it's just pulling up through the bearing and not moving the bearing, so that's not going to work. Yeah, that hasn't worked. I'll shrink the collet back down so it'll drop back to its starting point. So this time let's try to help this flimsy cheap tool do its job. I'm going to drive some wedges, so just chisels basically, down into these collet grooves and help them expand and stay expanded so they don't pop out. Okay, let's give this a try, see if this is going to work or not. And I think it is. All right. Well, that was a bit of a struggle, but the bearing is out. Alright, so it's a bit of a struggle. Probably there is a much better way to do that. That falls in the category of me using the tools that I have to get it done. So if anyone knows a better way that doesn't involve buying a several $100 specialty tool, then certainly drop that in the comments. So not elegant, but bearings out. So as I mentioned before, I'm just going to leave this bearing in for now because I need it for something else. But how I would address that, of course, is just to pull the snap rings on the annular bearing, get the annular bearing out, and then use a steel driver to drive the other needle bearing into the case. And then front housing is fully assembled or disassembled, and that's it, ready for cleanup and reassembly. So in the next video we'll probably start to reassemble the low range unit. Alright, thanks for watching.